Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video we are going to solve question 38, which is based on the Benzyne intermediate, again from the GATE 2023 paper. So let us first read the question. This is a reaction that is given, and what we have to do is we have to identify the product P in the given reaction. So what will happen is the first step is we have to form the benzene, formation of the benzyne intermediate. First step is formation of the benzyne intermediate. So now what exactly is a benzyne intermediate? Let us first see the structure of benzyne intermediate, and then we will see how did I come to know that a benzyne intermediate will be formed. Okay, so the structure given to us is, what is benzyne intermediate? Benzene, it has three double bonds. Benzyne, YN means triple bond. So one of the bonds is multiple bonds is a triple bond, and the remaining two are double bonds. So this is what we have to form. So how it will be forming? So benzene, which groups are attached? Silicon. To this silicon there are three methyl groups that are attached, and then there is a OTF group. Okay, so what will happen is CSF is given, cesium fluoride, this is F minus, cesium plus. So what will happen? Fluoride is electron rich, and we know silicon has vacant d orbital. So what will happen? This F minus will donate electron in the vacant d orbital of silicon. So always remember, the bond between silicon and fluorine and silicon and oxygen is very strong. Why? Because the silicon has this vacant d orbital that can accept electrons from the lone pair of fluorine as well as oxygen. So these bonds, whenever there is a possibility of silicon fluorine bond or oxygen silicon bond, they will definitely form. So as we as fluoride attacks the donates electrons to the vacant d orbital of silicon, the opposite bond, that is a sigma bond, becomes weaker. It will give electrons to this benzene ring. Okay, that is benzyne will be formed, and OTF is a very good leaving group. This is the trick to identify a benzyne intermediate will be formed is, first is there will be atom having vacant orbital. Okay, just like here it was silicon, atom having vacant orbital that can accept electrons from from electron with donating group like fluoride. Atom with vacant orbital. Second is there will be a very good leaving group. Very good leaving group. Okay, here it is OTF. It can be any other group as well, like OTS. Okay, OTS. This is called tosylate. Okay, now let us understand why this OTF is a good leaving group. What is the name of this group? I'll write here. OTF is what? It is triflate. This triflate. Let us see the structure of this. O minus, oxygen having three lone pair, negative charge. Then there is sulfur, double bond O, double bond O. Then carbon. To this carbon there are three fluorine atoms that are attached. Now there are two reasons why this negative charge on oxygen is stable. One is it is involved in resonance with the sulfur oxygen double bond. So this is one of the reasons that it is stabilized due to resonance. The second reason is all these three fluorine atoms, they can withdraw electron density via minus I inductive effect. So these also stabilize the negative charge. So that is why this is a very good leaving group. So what we will get is we will get our benzyne intermediate. Okay. So we have got our benzyne intermediate. Now the next step is to react this with the carbonyl compound that is given. Okay, so second step is reaction of the benzyne intermediate with reaction of the benzyne intermediate. So we have got our benzyne intermediate. Okay, now if you see this compound, okay, these two hydrogens, if you see, they are highly acidic. So it can easily donate H plus ions, and it can form what? Negative charge. That is conjugate base can be formed. Now this can attack any one of the carbon of the benzyne intermediate, and we will get a carbanion formation. So what we have got is benzene, negative charge, then there is CH, C double bond O, Me I am writing as CH3, and the other group is ester group, C double bond O, OCH3. Now there will be the next step is intramolecular nucleophilic addition. Intramolecular means within the molecule reaction is taking place. Which reaction is taking place? Nucleophilic addition. Nucleophile is added. This negative charge now it can attack any one of these carbonyl carbons. So the question is which carbonyl carbon it will attack. Now this is electron rich, right? So it will attack the carbonyl carbon which is what? Which is more electrophilic or electron deficient carbon. It will attack the electron deficient carbon. Now which is more electrophilic? So here if you see oxygen atom, it has lone pair which can donate electron density via mesomeric effect or resonance, via mesomeric effect here. Okay, it can donate via mesomeric effect. And here if you see methyl donates via which effect? Plus I inductive effect and hyperconjugation. So we know mesomeric effect is more dominant over inductive effect. So this carbonyl carbon is what? It is electron rich. Okay, electron rich, or we can say less electrophilic. Okay, less electron deficient. This is not electron deficient because oxygen is donating its lone pair, whereas this carbonyl carbon of ketone, it is what? It is more electrophilic. Okay, and hence this will be more reactive. Okay, so this will react with the negative charge. So what will happen is, okay, let me write here. Okay, so what will happen is this negative charge will now attack the carbonyl carbon of the ketone, C double bond O, OMe. So what will happen here is this negative charge will attack this carbonyl carbon. This will open up. This already has two lone pairs. Now what will happen? There is a bond formation between this benzene carbon and this carbon. Double bond has now become single bond, and here there will be three lone pair and a negative charge. Okay, what will be the next step? Okay, next step is this will form C double bond O, and this bond will break and the negative charge will come here on this carbon. Okay, all this takes place in a single step, but for better understanding I am drawing the bonds in between. Okay, why this negative charge is formed here? Because it is stabilized by two factors. One is the resonance with the benzene ring, that is, it is present at the benzylic carbon. Okay, another reason is this is stabilized by the carbonyl group of the ester molecule. The final product, now this negative charge will pick up proton and it will become CH2. Okay, and this has become C double bond O. Okay, so let us draw this properly. Benzene ring, we have ketone, CH3, I can again write back methyl, and here we have CH2, C double bond O, OMe. So this is the final product. Okay, so which is the correct answer? The correct answer is option A, C double bond OMe, CH2 and ester group. So the correct answer is option A. I hope you have understood the solution. First step was formation of the benzyne intermediate, then the benzyne intermediate reacts with the carbonyl compound, that is active methylene compound that is given, and then there was the intramolecular nucleophilic addition and we got the final product. I hope you have understood the solution. Thank you.